Okay, good morning, all of you. So today we'll start our new point, that is water jet machining. Okay, in the last lecture, I have given the just overview of this water jet machining. Today we'll discuss the one by one all the points regarding this water jet machining. So let us start with once again the introduction. So in this water jet machining, the high pressure water that allowed to pass through the nozzle, and the stream of that water which is coming out from that nozzle with a high velocity, and that velocity is near about 900 meter per second. So that stream of high velocity water, it is called water jet. Okay, I repeat, the stream of water which is coming out of nozzle with high velocity near about 900 meter per second, it is called water jet. Okay, and the high velocity of that water jet having twice the speed of our sound. Okay, when that high velocity jet of water, when it strike onto your workpiece, that time by action of that erosion, it removes the material very easily from that workpiece surface. Okay, here you can see the diagram also. Okay, we are taking water jet or water from the source. Okay, having the high pressure, high velocity through the nozzle, where hitting the workpiece with the help of water jet. Okay, and after hitting or after striking that water jet on the your workpiece, it will remove the workpiece, that the small parts or the small piece, it will remove. Okay, in the form of we are calling it is called craters or the debris. Okay, so in short, here I have written that in water jet machining, high velocity, that is up to 900 meter per second, water jet is allowed to strike a given workpiece, and during this process, its a kinetic energy is converted to its a pressure energy, and this induces the trace on the your workpiece surface. And when this induces trace is very enough high, that time unwanted particles of the your workpiece, okay, that will remove automatically. Okay, so whatever the removal of the material in this process is there, no, so that removal of the material, it is caused by the water jet only. Okay, so water jet is cutting tool for this process or in this water jet machine. Okay, remember, the water jet is act as a cutting tool. Okay, which removes the that your workpiece particle, okay, which will never burn that dulls or the break cutting action is there, no, so that is performed by the your water jet only. Okay, so this process does not generate any airborne dust. Okay, so we can call it is not hazardous during the your machining of the fiber or the composite and your asbestos also. Okay, which are minimum, okay, in this case or in this process. Okay, also whatever the quality of the machinery edge is there now, which is often during this process, it is usually superior to the other conventional cutting process. So this process is good for cutting and the sliding of the porous non-metal materials, okay, like wood or leathers or foam, etc. Okay, it is also used for cutting composite, then wire stripping and the deburring purposes. So remember that here high velocity water jet will act as a your cutting tool, and when it will strike from your nozzle, when it will comes out of your nozzle and when it will strike on your workpiece, that time its kinetic energy will convert into the pressure energy, and due to that it will induce the some trace on your workpiece surface. And when that induced trace will be the high enough, that time only it will remove the uh, your work particles of the workpiece. Okay, so that is called the removal of the material. Okay, you can see here. For now, here also in this process also we have to or we need to maintain some that nozzle tip distance, or it is also called stand up distance. Okay, the distance between your tip of nozzle and the top surface of your workpiece. So that distance we have to keep constant, okay, to remove the that removal of the material continuously. Okay, so in this figure I have shown that stand up distance. Again, that stand up distance, it will if you change, then there is a effect on your metal removal rate. Okay, that we are going to see, because the stand up distance, as we know, that it is one of the your our uh, process parameter, okay, which will affect the your metal removal rate. Okay, again, the nozzle material we have studied in the average jet machine. You can use our tungsten carbide or sapphire material. Okay, again, it's the shape that it may be the rectangular, or it may be the your circular. Okay, that again depends on the your application. Okay, but here main application is the slicing or the splitting, okay, of your composite or other non-metals, so wood or leather or foam. Okay, that we can do with the help of this water jet machining also, because this process is normally we are using for the cutting purpose, so water jet cutting also it is called. So this is the working principle. So now I will give only 2 minutes to draw this diagram. Okay, please draw this diagram. When in your exam, if they will ask about the working principle, that time you have to draw this diagram only, and you have to explain. Okay, simultaneously, just I will once again repeat the principle about this process. Okay, okay. Repeatedly, I am saying, okay, here, high velocity water jet is allowed to the strike on your given workpiece. Okay, and during this striking, the kinetic energy of your water jet is converted into your pressure energy, and this pressure energy induces the trace, okay, on the your workpiece surface. Okay, and when this whatever the industrial stress is there, no, is high enough, that time unwanted particle of your workpiece surface, that will remove automatically. Okay, so here also the removal, or that removal of the workpiece surface, okay, that will be happen due to erosion action only. Okay, because at the time of chapter number 1, okay, I have given the example of that water which is coming from your tap, and if you hit that continuously water on your stone or other aluminum also, okay, after um, some time it will remove the some particle from your wood or that aluminum metal also. Okay, so that striking is not kinetic energy, that induces the trace. Okay, please draw diagram immediately. Hurry up. This is a simple diagram I have shown. Okay, in a different book you will get the different diagram. Completed. So let us move further. So this is about the working principle. Now the next point is the setup of this water jet machining, or we can call equipments used for this water jet machining. You can see the diagram. Now as we need high velocity jet of water, okay, that means we should have the reservoir of the water. So here you can see we have the fluid supply tank. Okay, so water we have to take from our that water from this reservoir, we need to pump it. So pumping that water from this reservoir or the fluid supply, we need this pump. Okay, again, whatever the water is there in this reservoir, it may have some contaminant or the dust particle. So to remove that, we need a filter. Okay, then to increase the pressure of this pumped water, we need another hydraulic element that is called intensifier. Okay, and here I have shown the intensifier, and to control the flow of that water, we need a control system. So all I have shown you. If excess water is there, then to store that excess high pressurized water, we need a storage tank. So that storage, it is called the accumulator. Okay, then the required water jet or that high velocity water, it will comes to the it will goes to this your nozzle. Okay, now normal here they have shown the nozzle which is made of the sapphire material. Okay, so sapphire nozzle it is called, and, and through this nozzle you can strike the water, or you can hit the water on your workpiece. Okay, so you can see here water, I have shown the workpiece, and on that your water jet is hitting. Okay, so the here what are the components or the main elements of this water jet system? So your reservoir, then hydraulic pump, intensifier, accumulator, then control wall, and then your nozzle, water jet nozzle, and the flow regulator. Okay, so these are the main elements. Now let us discuss the how it is working through. Okay, that means the how material remove will be happen. So firstly, what happen? What will happen? Water from your reservoir, okay, pumped to the your intensifier, okay, with the help of hydraulic pump. Then the intensifier will increase the pressure of the water. Okay, again that pressure may be the up to 200 to 400 megapascal. And what are the excess supply pressure of water is there now after the intensifier? So that is normally sent to the your accumulator. Okay, for temporary storage purpose, because the function of the accumulator is to just store the water. Okay, again that water is the pressure water, because that we got from the intensifier. Okay, so what are the excess amount of pressure water is there for temporary storage, we have to send it to accumulator, and the required quantity of the pressure water is there, no, so that we have to send, or that we have to enter into the your nozzle. Okay, again before entering we need to control that. So control wall is there, and the flow regulator I have shown here also, control wall and the flow regulator. Okay, so the control, what will it will do? So control control the direction of the water, and flow regulator, it will regulates and control the flow of flow rate of your water. Okay, and then water pressure, that pressurized water, it will comes in the your nozzle. And the nozzle, what is the function of nozzle? The nozzle will convert your pressure energy of the water into the kinetic energy. Okay, so which is having the very high velocity. That kinetic energy, uh, pressure energy of the water, it will convert into the kinetic energy. Okay, and then when the high velocity water jet comes out of your nozzle, and when it will strike to your workpiece, that time your pressure energy, the kinetic energy, it will convert into the pressure energy. Okay, and it will induce the some stress on your workpiece surface. And when that stress, whatever induced stress is there, when it will enough, that time this induced stresses are used to remove the workpiece surface, or that some particles from your workpiece surface. Okay, so that is the working principle, and with the help of the all elements I have explained. Okay, so before go discussing again one by one this all the components, please draw this diagram. So this is diagram of equipment used in water jet machining, or it is you can call the what are the different elements, or you can call it as a setup. So again I will give two to 3 minutes to draw this diagram. Okay, this is a simple diagram I have shown you. We should know the which are the elements in the setup of the water jet machining it is required. All of you please draw this diagram. Okay, so now I will explain to this components, okay, or the elements you can call. So what is the role of the reservoir? So it is used to store the water. Okay, that is to be used in the machining operation. Okay, then our next component is a hydraulic pump. Okay, so what is the function of a hydraulic pump? Okay, to lift the water from your reservoir, and it need to and it will supply to that water to the intensifier. That is function. So after pump we have the intensifier element. So it takes the water from hydraulic pump, and it will pressurize that water to a desired level, and then it will send to the for next element. Okay, to the next element. Then we have the another element, that is accumulator. So it is used for temporary storage of pressurized excess water. Okay, temporary temporary storage of excess water, pressurized excess water. Okay, which is supplied from your hydraulic pump. Okay, through your intensifier. Uh, okay, now again in that how it will work. So when there is a shortage of water, of the pressurized water, okay, to your machining area, then the stored water in the accumulator is used to maintain the constant pressure in the system. Okay, so this is used to maintain the constant pressure in the system, and again to eliminate the pressure fluctuation. So that for that purpose only we are added this accumulator element. Okay, then as we know that control valve, so it is used to control the direction and also pressure of your pressure water which is to be supplied through the your nozzle. Okay, and again we have the that flow regulator. So normally the flow regulator it is used to regulate the mass flow rate of your water, okay, in this system. Okay, and the last and very important point that is part is the or element is the nozzle. Okay, so we know that nozzle it converts your pressure energy of pressure water pressurized water into the kinetic energy, okay, which is having the very high velocity around 900 meter per second. Okay, and it has again over you can see its diameter is it is in decreasing, so it has the orifice. Okay, uh, the diameter varies from 0.08 mm to 0.5 mm. Okay, and the material used for the nozzle, normally in this water jet machining they are using synthetic sapphire, okay, which is wear resistant and easily machinable. Okay, so these are the elements. Okay, now let us move for the process parameters, or the it is also called controlling parameters. Okay, which are the parameters which will affect the performance of machining, or we can call which will affect the material removal rate. It is called the process parameters. Okay, and for this process water jet machining, now for abrasive jet machining, there were different parameters. Now here we have the different parameters. So here I have mentioned the stand-off distance is the one of the process parameter. The fluid pressure is there. Again, feed rate of the it is all traverse rate also, and the jet fluid. Okay, and last is the nozzle diameter. So these are the parameters which are adjustable and which are used to control the your process as per the your requirement. Okay, in the but here as per the requirement, that means we have to keep in our mind that is for what purpose or what application we are using. So depend on that we have to control this parameter. It is called controlling parameters. Okay, so first parameter is the stand up distance. So now this stand up distance is what? It is a gap. As we know that it is a gap between the your jet nozzle, that tip of your nozzle and the surface of the your workpiece. Now here material removal increases with the increase of stand off distance up to certain limit, and after that limit or up to that optimum value, your material removal rate it will falls gradually if you will continually increasing the stand off distance. Now as we know that in the average jet machining also, if you increase the nozzle tip distance or the stand off distance, your material removal rate also increases, but up to certain limit, and beyond that limit it falls gradually. Okay, so same things happening here also in this case, in case of this water jet machining. Okay, so this is a stand off distance. Then second process parameter is the fluid pressure. Okay, so as we know that cutting at faster water jet pressure. Okay, so cutting will be the faster at your higher water jet pressure. Okay, if you increase your fluid pressure, definitely your cutting will be uh, that cutting rate or that will be faster. Okay, again, if you increase the pressure, it will increase the depth of cut also. Okay, it will increase the depth of cut. Again, the same thing happening here also. Okay, as like average jet machining. Then next parameter is the traverse rate. So whatever the thick materials are there, no, so that can be machined without difficulty at high jet pressure. Okay, and you can call low traverse rate. Okay, you can maintain low traverse rate. That time also you can cut or you can machine thin materials, okay, without any difficulty. Then we have the another parameter that is jet fluid. Okay, so it must have low, in this case, in the water jet machine, it must have low viscosity to minimize the energy losses. Okay, so whatever now normally in this case where is water. Okay, so there we have to make low viscosity, okay, to minimize the energy losses, and your jet fluid should or must be non-corrosive, non-toxic. Okay, and your fluid should be commonly used and inexpensive. Okay, and here we are normally using uh, water only. Okay, another parameter is the nozzle diameter. So whatever the internal diameter of nozzle will be there. So usually it's a ranges from 0.07 to zero point 0.5 yeah, millimeter. Okay, that is already I have told you. Okay, 0.07 to zero point 0.5 mm, and these nozzles are made of the synthetic sapphire material. Okay, which is wear resistance, as well as it is easily machinable also. Okay, so these are the process parameters. Okay, here I have not showing any graph because of whatever the graph which I have showing the at the time of abrogate machining. So same graphs are applicable here also, because if you increase the stand-up distance up to certain limit, your material remove rate also going to increase, and after the certain that maximum point, if you continually increasing that nozzle tip distance or stand-up distance, your material remove rate is going to fall gradually there. Okay, and if you increase the fluid pressure, material remove rate will be increases, as well as your depth of cut will increase. Okay, so these are the process parameters. Okay, please write, just note down this four, five parameters. Okay. Okay. Now let us discuss the advantages. Uh, okay, advantages of this water jet must be. So the basic or the general advantages, firstly I have given, that is it is a fast process. It is fast process. Then it prevents the formation of heat affected zones on the your workpiece, because here we are using water as your cutting tool. Correct. So there is no need to go for there is no issue of the heat affected zone. Okay, so it prevents that formation of the heat affected zone on your workpiece. Again, automatically, as we are using water with the high velocity, so automatically it cleans the surface of your workpiece also. Okay, again it has excellent precision. Okay, it has excellent precision. Again, what are the tolerance is there? So the tolerance, it is up to 0.005 mm can be often using this water jet musting process. Okay, and here, uh, so this process does not produce any hazardous gas. Okay, again this process is very eco-friendly. So these are the advantages. Now, disadvantages also I have given. So here only soft materials can be machined. Okay, because if you want to cut the hard material using this water jet machine, then it takes more time. Okay, so rather going to this water jet machine for hard material, you can go conventional also, for that much time it is taking. So for effective usage of this machine, you can use for machining of the soft materials, you can use this machine, this process water jet machining. Okay, again that will be effectively. Again, very high thick metal cannot be machined. Yesterday we have seen in the videos how the cutting happening using this water jet machine. Okay, again the whatever the investment is the initial, that is also very high. Okay, again for this mass production purpose we cannot, this process is not suitable. Okay, so these are the disadvantages of. Now the last part is applications of this water jet machinery. So here I have mentioned some applications. So this process is useful for cutting materials which are porous, fibrous, fibrous, then granular or soft also. Okay. Now, uh, in some book they have not stated about the fibrous materials. In some book they have given the, this is what are the application I have taken. This is from one of the textbook. Okay. So this process is useful for the cutting materials which are porous, then granular or soft. Okay, again it includes the material like corrugated boards, then rubber, granite, then plywood, glass, aluminum also. Okay, again to this process can be used to cut wood, ceramic, composites, leather, foam, wire stripping, and deburring purposes also. Okay, again in aerospace and other similar industries. Okay, in that again cutting of the asbestos is done by using this water jet, because there we can we need to minimize the airborne dust in the atmosphere. So if you use the water jet, then there is no issue of the that airborne. Okay, again this process used to cut fiber glass and polyethylene automotive parts. Okay, so these are the applications. Now again, so this is a application. Again in detail if you want to go, that is which type of nozzle, we can use in the depending on the application. So that also we are going to see in the abrasive water jet machining, because the combination of abrasive jet machining and the water jet machining. Okay, so that we are going to learn in AWJM process. Okay, so this is about the water jet. Now let us take some summary about this water jet machining. Okay, now I will ask some questions like MCQ type question. You have to give the answer. Okay, so water used in water jet machining. Okay, answer is sorry, option is can be reused directly. Then second option, cannot be reused or can be reused after a post process treatment. Okay, whether we are reusing the water or not in this process. What about the answer? Okay, we are not reusing the water. Okay, because take fresh water, there is no issue. Okay, but to reuse the water we need that water treatment and other things. Okay, so it is better to take fresh water. Now one thing I forgot to mention that here, okay, in this diagram you can see when water jet comes outside the nozzle, no, then it travels at a very high speed, okay, usually more than the our sound velocity also, that is up to 900 meter per second. And to minimize the exposed length of your jet, okay, so from safety point of view, to minimize that process noise, okay, here drainage, or it is also called catcher, okay, that means the slot type or the tube type is used, catcher, okay, one of the drainage type. So normally that catcher is, it is attached in the your drainage, this hose, okay. And what is the purpose of this catcher? The catcher used a you just hard and replaceable insert, okay, to break the jet quickly, okay, and completely, so before it reaches bottom of your tube, okay, bottom of your tube, okay. So slot type catcher also used, or tube type. So catcher, it is required in this water jet machine also. Now as like this, as we are using catcher in this for the before that drainage, no, so same that catcher element also required in the abrasive water jet machining, so that we are going to see in the next lecture. Now I'll wait for 1 minute. Just, we'll discuss the difference between the water jet machining and abrasive jet machining, okay. Now in this slide I have shown the similarities and the differences between the abrasive jet machining and water jet machining. You can see, as we know that both abrasive jet machining and water jet machining directly utilizes your mechanical energy. Okay, it may be in the form of kinetic energy, or it may be in the form of pressure energy. Okay, and that energy, it is used or it is utilized to remove the metal from your workpiece. Okay, by erosion action. Okay, so this we have studied working principle of abrasive jet machining, okay, this also. and just we have seen the water jet machining also. Now let us discuss the similarity first. So as we know that both are non-traditional, non-conventional machining processes. Okay, and none of them them is considered as a hybrid process, and both are mechanically energy based non-traditional machining processes because they directly utilize kinetic energy to remove the material. Then both the processes require appropriate nozzle for converting pressure energy of your fluid into the kinetic energy. Okay, again, the whatever performance of average jet mastic or water jet mastic, it does not depend on the electrical and the thermal conductivity and the chemical inertness of your workpiece material. So again, none of these processes is associated with the burr formation, thermal damage, or the heat hazardous zone. Okay, these are the similarities. Again, both the process can be integrated with the CNC system for efficient control and precise delivery of your jet. Okay, so these are the general similarities. Now the important is the differences. Okay, so again, I have made two columns. In one column, you will get the points about the average jet masting. In second column, you will get the points regarding water jet masting. So first point about the water jet masting is the here high velocity jet of air and abrasive mixture is utilized for material removal purpose. Okay, high velocity jet of air plus abrasive mixture is utilized. Okay, and in case of water jet machining, high velocity jet of pure water is utilized for a removal of the material. Then in case of the abrasive jet machining, the working medium for this abrasive jet machining is dust free and dehumidified air. In case of water jet machining, working medium is clean water. Okay, then for our average jet machining, air compressor is used to deliver pressurized air. And in case of water jet machining, in place of air compressor, here a liquid pump along with intensifier, it is used to deliver pressurized water. Okay, then in case of water abrasive jet machining, air whatever the air pressure is there, no, so typically it remains within 2 to 10 bar only. But in case of water jet machining, water pressure remains very high. It is typically near about 2500 to 4000 bar. Then velocity of air abrasive mixture jet. Okay, in case of abrasive jet machining, velocity of air abrasive mixture jet, it when it comes out of the nozzle, so that velocity remains in order of 10 to 100 to 300 meter per second. But in case of water jet machining, velocity of water jet is very high. When it comes out of the nozzle, that remains around 900 meter per second. Again, in case of water average jet machining, there always exists a tendency of glint embedment, okay, on your uh, machined surface in this average jet machining. Glint embedment means what? In Marathi we can call जे particle remove झाले ते तिथे चिटकून राहणे. Okay, so this may affect surface property and the appearance of your cavity also. But in case of water jet machining, there is no, it is not associated with any risk of any embedment. Okay, as there is a no abrasives are used in this water jet machining. In case of abrasive machining, it cannot be employed in food processing industry because we are using the abrasive particles. So due to risk of abrasive contamination, we cannot use this process for in food industry. But water jet machining, it is preferred and hygienic for slicing food items like frozen meat and fish purposes. Again, abrasive jet machining, it can be efficiently machine hard metals, okay, include metal. In fact, this abrasive jet machining is preferred for machining hard brittle metals and ceramic also. Okay, uh, but in case of water jet machining, water jet does not possess enough power for cutting metal or ceramic, so it is suitable for cutting softer materials like wood, rubber, or leather or foams. So here within one slide I have given the diff, uh, differences. Okay, so this is about the water jet machining and aero jet mustang difference. So I will give 2 minutes to write down this similarity difference between the AJM and WJM. Okay, and the time being, please write down your roll number in the chat box. Simultaneously, I will write your attendance also. Okay, don't leave this meeting. Firstly, complete this difference. Okay, then leave the meeting. Only 22 students has written their roll number. Other students, please write down your roll number. Okay, now you can leave this meeting. Okay, thank you very much.